scientist. My troubles with explanatory terms only deepened during my medical student and postdoctoral years after I realized that my dear mentor, André Grastian, and my postdoctoral advisor, Cornelius Case Vanderwolf, shared my frustration. Too often, when we do not understand something, we make up a word or two and pretend that those words solve the mystery. Scientists started the 21st century with a new goal: understanding ourselves and the complexity of the hardware that supports our individual minds. All of a sudden, neuroscience emerged from long obscurity into everyday language. New programs have sprung up around the world. The BRAIN initiative in the United States put big money into public-private collaborations aimed at developing powerful new tools to peek into the workings of the brain. In Europe, the Human Brain Project promises to construct a model of the human brain, perhaps an overambitious goal, in the next decade. The main targets of the China Brain Project are the mechanisms of cognition and brain diseases, as well as advancing information technology and artificial intelligence projects. Strikingly, none of these programs makes a priority of understanding the general principles of brain function. That decision may be tactically wise because discoveries of novel principles of the brain require decades of maturation and distillation of ideas. Unlike physics, which has great theories and is constantly in search for new tools to test them, neuroscience is still in its infancy, searching for the right questions. It is a bit like the Wild West, full of unknowns, where a single individual has the same chance to find the gold of knowledge as an industry-scale institution. Yet big ideas and guiding frameworks are much needed, especially when such large programs are outlined. Large-scale, top-down, coordinated megaprojects should carefully explore whether their resources are being spent in the most efficient manner. When the BRAIN initiative is finished, we may end up with extraordinary tools that will be used to make increasingly precise measurements of the same problems if we fail to train the new generation of neuroscientists to think big and synthesize. Science is not just the art of measuring the world and converting it into equations. It is not simply a body of facts, but a gloriously imperfect interpretation of their relationships. Facts and observations become scientific knowledge when their widest implications are explored with great breadth and force of thinking. While we all acknowledge that empirical research stands on a foundation of measurement, these observations need to be organized into coherent theories to allow further progress. Major scientific insights are typically declared to be important discoveries only later in history, progressively acquiring credibility after scrutiny by the community, and after novel experiments support the theory and refute competing ones. Science is an iterative and recursive endeavor, a human activity. Recognizing and synthesizing critical insights takes time and effort. This is as true today as it has always been. A fundamental goal in neuroscience is identifying the principles of neuronal circuit organization. My conviction about the importance of this goal was my major motivation for writing this. Writing a book requires an internal urge, an itching feeling that can be suppressed temporarily with distraction, but always returns. That itch for me began a while ago. Upon receiving the Cortical Discoverer Prize from the Cajal Club, American Association of Anatomists, in 2001, I was invited to write a review for a prominent journal. I thought that the best way to exploit this opportunity was to write an essay about my problems with scientific terms, and argue that our current framework in neuroscience may not be on the right track. A month later arrived the rejection letter. Dear György, I hope you understand that for the sake of the journal, we cannot publish your manuscript. I did not understand the connection between the content of my essay and the reputation of the journal. What was at stake? I called up my great supporter and crisis advisor, Theodore Ted Bullock at the University of California at San Diego, who listened carefully and told me to take a deep breath, put the issue on the back burner, and go back to the lab. I complied. Yet the issues kept bugging me. Over the years, I read as much as I could find on the connection between language and scientific thinking.